With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's begin with the question. And in the question it says that a cylindrical tank having cross-sectional area A is equal to 0.5 meter square is filled with two liquids of density rho 1 is equal to 900 kilogram per meter cube, rho 2 is 600 kilogram per meter cube, to a height of h is equal to 30 centimeter as shown in the figure. A small hole whose area is 5 centimeters square is made in right vertical wall at a height y is equal to 20 centimeters from the bottom. Now horizontal force F, which is right here, is applied on the tank to keep in the static equilibrium. So that means this force is balancing the force or the upthrust which is produced by the velocity of the efflux. And the tank is lying on a horizontal surface. So neglect the mass of the cylinder tank in comparison to the mass of the liquid, and we have to calculate the force required to keep the cylinder in equilibrium position, in static equilibrium on a smooth horizontal plane. That means this surface is smooth here. So now we are going to solve this problem. So what we do now, we will make an area orifice here. We take a point just outside, that is B, and just inside, that is A. We are taking these 2 points and applying Bernoulli theorem, which is just outside. The point B is just outside and the point A is just inside. And we know that according to Bernoulli theorem, if according to Bernoulli's theorem. Okay, so in the Bernoulli theorem, the sum of pressure energy, let's say pressure energy at A is PA, kinetic energy KEA, and the potential energy is also at that point, it is PEA, is equal to the potential energy of B plus kinetic energy of B and potential energy of B. Now since point A and B are at the same height, so because of that the potential energy of A and B are equal and they will be cancelled. Now one more thing, the velocity is at the outer point of the cylinder, not inside. Inside the water is still in the static state. So with that we can say kinetic energy of point A is 0. So rest thing remains is pressure energy of A is equal to pressure energy of B plus kinetic energy of B. Now talking about the pressure energy of B is, pressure energy of A start with, so here P naught is acting at the upper point, then when we move lower, then it is rho 2 G H, then again rho 1 G into H minus Y. So till here the pressure of A is acting. Now point B, since it is outside, so only pressure that is acting here is P naught, and this is half rho 1 V square. So this is what we have. Now what happens here, this P naught and this P naught are going to be cancelled, and now we'll put all those values that is given in the question, rho 2 G H and all that. So here rho 2 is 600, G is 10, and H is given here is 600. I think it is 60 centimeters, so it will be 0.6. So here it is 0.6 plus 900, that is rho 1 into 10, and the value of y is given in the question is 2. So h minus y will be 40 centimeter, and that will be 0.4, and this is equal to 1 by 2 rho 1, and the value of rho 1 is again 9, we would again here is 900 kilogram per meter cube, and it is V square. So when we calculate this, the value of this will come out here as, this will be come out here is, and when we multiply by 2 also, which is here in the denominator on the right hand side, this will be 14400, and this is divided by 900, and this will be equal to v square. So this 20 is cancelled, and then v square will come out here is equal to 16. That means velocity of efflux come out here is 4 meter per second. So this is what we calculate so far, is the velocity of efflux. Now we are interested to calculate the force that is acting here. So if we draw the diagram, here it is. So what is happening, since the water is coming out from here, so due to this there is a thrust that will act here, and the direction of thrust will be into this. This is Ft. And other forces that are acting here is the mass of this, that is mg, and this is balanced by the normal reaction. Since it is in contact with the ground, so these two forces are being balanced. Now to balance the up thrust, we need another force that is shown in the diagram, that is F. So that means this force F is equal to F thrust, and up thrust will be equal to Ft. It is rate of change in momentum. Rate of change in momentum. This is what we have to consider. So rate of change in momentum will be equal to Ft. It is d by dt of m into v, right? And further, when we move to solve this, m will be density into volume. So this is density is rho, volume is a into l into v. So density and a and the density is constant, and dl by dt will be velocity. So here thrust force will be equal to rho a v square, and the value of density here that is given, density is certainly rho 1 here, so it is rho 1. Now the value of rho 1 is given as 900 kilogram per meter cube, so it is 900 kilogram per meter cube into velocity, that is the square of 4, it is 60, and the area is 5 centimeter square. So when we convert this into meter square, this will be 5 into 10 raised to the power minus 4. So when we multiply, this is Ft is equal to, Ft will be equal to 72000 into 10 raised to the power minus 4. So Ft will come out here is 7.2 Newton, and this is certainly equal to the force F that is applied. So this is the final value of force that is applied to put the cylinder is in equilibrium position. So with that we can say that the second option is the right answer of this question. This is about this question. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.